So example here. Consider a probability experiment that consists of tossing a coin and then rolling a three-sided die. Okay, now I want you guys build the sample space. Okay, sample space. Use the diagram. Okay, use the diagram. Use the diagram to build or construct the sample space. And try it. I'm gonna give you guys 1 or 2 minutes. Try it. Try yourself. Okay. Please check your previous notes. Okay. I taught you guys 2 examples in the last class. So just follow the steps you learned from the last class. I think you should be able to figure it out by yourself. Okay. Okay, I'm gonna write down the answer on board. Let's take a look. So we conduct an experiment consists of tossing a coin and rolling a three-sided die. So we have what? A coin is have 2 possibilities. It's a head or tail, right? A head or tail. And then we have 6-sided die. That means we have 3 scenarios for each head, right? For each head, we have 3 scenarios. The die is 1, 2, 3, right? For tail, gonna be 1, 2, 3. Okay. So we have some combinations or outcomes. So outcomes. After you draw this diagram, then you can easily tell the outcomes. That could be H1, H2, H3, T1, T2, T3. Okay, T1, T2, T3. And the sample space is what? Sample space is the combination of these outcomes. By definition, sample space equals what? Equals the combination of all these outcomes. Just list all of them. Okay, list all of them. That's the sample space. And now the event. Tossing a tail and rolling a number that is less than 2. Try this one. Oh, the event. Sorry. No brackets. Write down the event. Tossing a tail and rolling a number that is less than 2. Okay. Write down the event. Okay, I'm gonna write down this answer on board. I think it's pretty straightforward. So tossing a tail, that means it's T, right? And rolling a number that is less than 2 should be this guy, right? So the event, this guy should be T1. That's it. Very simple and straightforward. Now I want you guys write another event. The event tossing ahead. Okay, try this one for me. Okay, so I'm gonna write down the answer for this guy. So tossing ahead is H, right? So that's nothing about the rolling a number. So the only three outcomes satisfy this event. So it should be H1, H2, H3. That's it. So that's the sample and events that we learned from last class. Okay, and that's it. We're going to move on to the next chapter, the fundamental counting principle. So today we're going to learn a very important principle we called fundamental counting principle. Okay. The fundamental counting principle. If one event can occur in m ways, and a second event can occur in n ways, then the number of ways the two events can occur in sequence is m times n. Okay, this rule can be extended to any number of events occurring in sequence in sequence. Okay, so let's take a look at the fundamental counting principles. Fundamental counting principle is include all the possible events. For example, one event occurs m ways. Okay, for example, and the second event occurs n ways. So how to calculate the total number of ways of these two events? That should be m times n. M times n. Let me give you guys an example. For example, here, we do experiments that we have two events. The first event is tossing a coin. And the second event is rolling a three-sided die. Okay, so for tossing a coin, how many ways we can have? We can have head or tail, right? We have two ways for the event coins, tossing a coin. So we have two ways. However, for the three-sided die, or rolling a three-sided die, we have three ways, right? We have three ways. 1, 2, 3, right? 1, 2, 3. So what's the total number of ways? The number of ways of these two events gonna be 2 is 2 times 3. Okay, should be 2 times 3 equals 6. That's the total number of ways for the last examples. Because when you throw the coin, there are only 2 ways. One is head, another one is tail, right? Another one is tail. So 2 ways. When you're rolling a 3-sided die, there are 3 possibilities. 1, 2, 3, right? So 2 times 3 equals 6, right? So we have a total 6 ways. Total 6 ways. Now I have a question. For example, tossing a coin, then rolling a for example 5-sided die, and then identifying the color of a rainbow. Okay, rainbow. So now, could you tell me how many ways they are? Try it. Identify the color of rainbow. Okay, so we have 3 events, right? We have 3 events. For each event, how many ways, right? Think about it. We can use fundamental counting principle to solve this type of problems. What's the answer? Do you know? Huh? Could you tell me?
I got 70. I don't think that's right.
70.
Yeah. Well, for the rainbow, like. Well,
7 colors.
Yeah.
There are 7 colors, huh?
Yeah. So would you do like? Would you multiply all 3 of those together?
Yeah, you're right. 70. You're right.
Okay.
You're right. I thought you gave me a wrong number about the rainbow colors.
Mm-hmm.
Actually, everybody should know it. 7 colors.
Yeah, no, I had to like write out the acronym, so I was trying to think of it. I was like, what'd you do? Yeah.
Okay, because the this example is originally chosen from my mind because my baby like rainbow.
Oh.
So tossing a coin, we have how many ways? We have head or tail, 2 ways. 5-sided die is 5. How many colors? 7. 70. Right. Very straightforward. Very straightforward. Okay, now I'm gonna give you guys a little bit complicated example. Let's take a look. Another example. You are purchasing a new car, the possible manufacturer car sizes and colors are listed in the table. Now let's take a look. Manufacturer, car size, color. The fourth one is Ford. Compact, white. And the second scenario, GM, GM, middle size, red, Honda. Okay, we can have more black, B, green, G. Now asking how many ways we can choose, or how many possibilities. Okay, try these problems for me. Okay, so if I give you this table includes the manufacturers, car size, color, right? So you're gonna have these multiple choices. So now I want you guys calculate how many choices, okay? You get it? You tell me the answer. Let me check the answer. How many?
7.
No, you make a mistake.
24.
You're right. You're clever.
3 times 2 times 4.
Yeah, that's it.
Okay.
Oh.
Okay.
So possibility for the manufacturer is 3. You have 3 choices. How many choices for the car size? 2 choices. How many choices for the colors? 4. Right? That's the fundamental counting principles. So you multiply all the ways. That means the choices. Multiply all the choices. And then you're going to get the total number. That's it.
Graph wrong. Like the way I looked at it, it's still use the 4 and white. Like I didn't apply it from like all the way from.
Okay, that's it. I think it's not too hard, right? Just count the ways. Let's continue. Now I'm gonna give you guys the tough examples. Example 4. The access code for a car's security system consists of 4 digits. Each digit can be any number from 0 through 9. Okay. We have 4 access code. The easiest way for you guys to do is draw 4 boxes. Okay, 4 boxes. And the first one is the first digit. And second digit. And third digit. And the fourth digit. Okay, 1, 2, 3, 4. And now, how many access code are possible? Access codes are possible when the first one, each digit can be used only once. Only once, and not repeated. Okay. This one is a little bit tough. Be careful. Each digit can only be used once. Only once. It's not repeated. Okay. So now basically, you have the number is 0, 1, 2, 3, blah, 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 to 9, right? And you need to fill these 4 boxes, right? You have 4 digits. 4 digits. You need to fill these 4 boxes. So use these numbers, right? When you fill this one number here, to fill this first box, we couldn't, the second box couldn't use the same number from the first box, okay? And the same thing, the third box couldn't use the number from the first box and second box. And the last box couldn't use the number from the first, second, and third, okay? So that's the principle. Think about it. I gave you guys 1 minute. It's not too hard, okay? It's not too hard, actually, if you think through the process. So for the first box, how many ways? For the second box, how many ways? For the third box, how many ways? For the fourth box, how many ways? Then use the fundamental counting principle, multiply together, right? That's the things way to calculate it. Okay, now I'm going to show you guys the results. So we have, for this type of problems, you just need to draw 4 boxes in case you make a mistake, because we have 4 digits, right? 4 digits. So for the first digit, how many choices for the first box? 10, very good. How about the second box? 9, very good. How about the third? Fantastic. So what's the results? So multiply all of them, you can multiply all of them, you're gonna get what? Um, that's it. That's it. Okay. Now let me try the second one. Each digit can be repeated. Okay. Okay, let's take a look. Let's take a look. So we have 4 digits. 1, 2, 3, 4, right? And for the first digit, how many ways? We have 10, right? Oh, some of you might count it's 9. That's wrong because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are there are 10 possibilities, right? 10 possibilities. It's not a 9. Okay. So be careful. We have 10 possibilities or 10 ways to fill the first digit. How about the second digit?
Yeah.
Right. Actually, they can be repeated. So we have 10,000. Okay, that's it. Now let's take a look. Another one. The question will become tougher and tougher. Three. Each digit can be repeated, but the first digit cannot be 0 or 1. Okay, try it again. Yeah, I think both you guys should get it. It's not too hard, right? It's not too hard, just a little bit tricky. So the first digit couldn't be a 0 or 1. That means we have 8 ways. For the other box, 10 ways, right? To get 8,000. 8,000. Okay, is that clear? Now the last one. Each digit can be repeated, of course. But the first digit cannot be 3 and 4. The second digit cannot be even number. The third digit cannot be a even number. Third digit cannot be a odd number. And the last digit is greater than 4. Okay. Oh, it's a little bit messy. So each digit can be repeated, but the first digit cannot be 3 and 4. The second digit cannot be an even number. The third digit cannot be an odd number. The last digit is greater than 4. Okay, now try this one. It's a little bit complicated, but this is, this is the same principle. Follow the same principle. After you feel the possible for each box, then just multiply the weights or the possibility for each box, and you're gonna get the answer. Okay.
So if the second digit can't be what, even, and the third digit can't be odd?
Yeah.
That's
You're done? You're done? Very good. Very good. Fantastic. So let me write down the answer on board. So for the first box, corresponding to the first digits, cannot be what? 3 and 4. That means we have 8 possibilities, right? And for the second digit, cannot be even number. So we have total 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cannot be even number. That means we can choose odd number. How many odd number? 5, right? 5. And it cannot be an odd number. That means we can choose even number. 5. And is greater than 4. That means greater than 4 is these 5 numbers. You see it? Then multiply these numbers, and you're gonna get what? 1,000. Good job. That's it. That's the principle. Right? Fill the box. How many ways you can fill the box? The same way, or the same things, right? How you fill the box. So when you see something like the password or access code, something like that, you need to fill. Just write down the box. Okay, write down the box and then calculate the ways. How many ways they can have, and then multiply them. Okay, that's the strategy to solve this type of problems. So far, any questions? No question. It seems too easy for you guys. Now let's continue. Definition. Classical probability is used when each outcome in a sample space is equally likely to occur. The classical probability for an event E is given by, let's take a look, PE equals number of outcomes in event E divided by total number of outcomes in sample space. Okay, so the classical probability, be careful, is the outcome of in a sample that equally likely to occur. Okay, so equally likely to occur, and the probability for a specific event, for example, PE, that is the total number of, or the number of outcomes in event E divided by the total number of outcomes in sample space. Okay, the total number. Be careful, the keywords is total number. Okay, number of outcomes in event E and the total number of outcomes in sample space. And previously, in the last class, we already mentioned how to construct like sample space, right? Sample space. Today, we're gonna use this terminology or concept to calculate the classical probability, okay? And outcomes, for example, here for event E, number of outcomes divided by the total number of outcomes. And in the previous example, for example, here, right? Here. So for this example, we know tossing a tail and rolling a number of that is less than 2 without the event A, how to calculate the probability of A and follow what? Follow this formula. So number of outcomes in event E. So how many outcomes in event A? That's 1, right? And how many outcomes in the sample space? The total number of outcomes in the sample space is what? It's 1, 2, 3, 4, 5, 6. The probability for the event A should be 1/6. Okay. The same things. How to calculate the probability of PB? How many outcomes for the B? 1, 2, 3. 3 outcomes. Okay. How many outcomes in the summer space? 1, 2, 3, 4, 5, 6, 6. Right? And the probability for the event B is 1/2. That's it. So that's the principle. Now I'm gonna give you guys an example. Let you guys try it. Okay. Right.
So you need to be paying attention.
You roll a 6-sided die. Find the probability of each event the first event A, rolling a 3. Okay. Now, how to calculate this guy? For these specific cases, the cases, you roll a 6-sided die. How about the summer space? Do you have any idea? Summer space? There are 6 summer spaces, 6 outcomes, right? For the summer space, right? Because we want to know the total number of outcomes in summer space, right? So you need to list all the outcomes. For the summer space, you can be a 1, 2, 3, 4, 5, 6. There are 6 possible ways, right? 6 possible ways because there is a 6-sided die. Okay. So the event A is 3, right? Rolling a 3, so that the event of 3 is 3. And now, what is the probability of rolling a 3? That's gonna be the outcomes in event A. How many outcomes in event A? The number of outcomes in event A is 1, right? Just 1 outcome. Just count the number. How many numbers there? It's 1 number, right? So how many total number of outcomes in summer space? 1, 2, 3, 4, 5, 6, 6. That's it, right? That's it. So you needed to know the outcomes in events E. That means the specific event here, right? And you needed to know the total number of outcomes in summer space, right? So that means you need to list all the summer space and count it. How many possible ways, right? How many possible ways? So here is 6, right? 6. And for event A, it's only 3. So here's a 1, right? 1 number, right? Now, I want you guys try this one. Event B, for example. Rolling a number less than 5. Okay, try this one for me. So the first thing you need to find how many outcomes in event B, right? Event B is rolling a number less than 5. And then the number divided by the total number of outcomes in summer space, that are going to be the probability. Okay. So follow these steps. Follow these steps. Did you get it? What's your probability? Good job. 2/3. Fantastic. Did you get it or not? You are struggling. 4/6 should be 2/3. Okay, so you can tell the event B is what? Event B less than 5. Less than 5 going to be 1, 2, 3, 4, right? So 1, 2, 3, 4. So that means probability loading a number less than 5 can be write down. There are 4 outcomes for the B divided by the total number. Total number is what? Is 6, right? 1, 2, 3, 4, 5, 6. And this guy gonna give you 2/3, right? 2/3. Now I'm gonna give you guys another one. It's very tricky. Event C. Loading a 7. Tricky. It's not tough. Did you get it or not?
I put 0 as or 0.
How about you? Okay, good job. You two are very smart. Okay. The answer should be 0. So for the event C, there's no number there. Okay, because 7 is impossible to happen because we have 6-sided die. One 6-sided die shouldn't be a 0. So if we use the probability formula, loading a 7, that means 0 number there. 0 outcomes. Divided by 6 equals 0. Okay, that's it. Very simple. And the last one, okay, the last one. Event D. rolling even number. Okay. Okay, let me write down the answer for you guys. So for the event D, how many events? 2, 4, 6, right? And rolling a even number gonna be 3 divided by 6, 1/2. Right? So how about the probability of rolling a odd number? The same thing, 1/2, right?
What?
How about the probability of rolling an odd number?
Same.
The same, right? You can think that's a common knowledge. If you throw a 6-sided die, common knowledge, you have 1/2 possibility to get the odd number or the even number, right? It's a common knowledge. Okay, so you guys know how to calculate the probability now, because most of you guys should be able to know why you should know the result. For example, if you're throwing a coin, that could be a head or tail. So how about the probability to get a head? 1/2, right? 1/2. But you don't know how to calculate based on the classical probability formula. You have head event is 1 outcome. The total number of outcome is 2. 1 divided by 2. That's the way you get this probability. Although you already know that's a 50%, but you don't know how you get it, right? Okay, I'm gonna wrap it up past here. Thank you for coming. Have a nice day. Keep it healthy. Okay.